Hey, Ash from All Things Dentistry, the place where we're passionate about sharing those unwritten hints and tips of dentistry. Well, if you're getting into endo and trying to get down fiber posts or getting in calcified teeth, you may want to look at doing a 3D guide. Now, what you can do is have a 3D guide printed, and then we use these sleeves from Steco, not sure how to pronounce it. And then you use this as an internal sleeve, and then they have a drill. They've got 2 drills. Oh, I have one attached here. Have a couple of drills, different lengths that are 1 millimeter in diameter, and then it can go through the sleeve, and then you can drill down the calcification, get past the calcification. These are really for anterior teeth, not so much posterior teeth, because it's a lot to put in a patient's mouth. Or you can get through fiber posts. That's what I love getting through. It's so much easier. But there are problems with 3D printing. Now, I'm far from being an expert. What I wanted to share with you, if you're going to get into this type of thing, and you're printing them yourselves, actually if you're designing them, because the next video I'm going to have up is designing this situation here. And before I design it, I want to hear some of the problems that you've encountered or any of the questions you have with regards to designing them. Put them in the comments below so I can create that video according to what you're looking for. So let me run through some of the inherent problems I've run into. You see a few cases here, and we've got different materials and whatnot. And just, again, I'm not an expert, and I'm not actually 3D printing them myself. I'm getting a lab or another 3D printing company who is an expert in 3D printing to have them fabricated. So let's go ahead and talk about, I don't know, shrink. So there are different materials. So this material here, so this is these two here, actually these three, let's clear these three are printed from a dental lab. So they use different materials. You can see there are different types of materials. I don't know if this is polished. I'm not sure. It didn't actually work. It was slightly frustrating. But this is, I think this is using a Straumann material. And then this is, I don't know, they're different labs. And this is a different type of thing here. You can see this looks like kind of a bridge, if you may. But actually what it is for, and I ran into a huge problem with this, but it worked amazing, is that this was designed to do an apico on an anterior tooth with a trephine. Now, problem number one of many of the problems, but the first problem is shrinkage. And you have to figure out in the software how much shrinkage. Yes, it's wintertime, but how much shrinkage is the hole going to experience from just the material being printed and the shrinkage? I'm not 100% sure. Put in the comments below if you can explain why this hole shrinks when you 3D print it. I still don't really understand. But what happens is I know the diameter dimensions of this outside. Actually, interesting enough, let me go into this. This trephine, which is used for implant removal, the outside diameter of the sleeve, this is actually 1 diameter, and this is actually 1 millimeter where these crazy, angry cutting teeth are. It's about 1 millimeter greater in diameter. Can you see that there? So I didn't know that when I first created these things, so now I do, because you see these in the literature. So this was actually for a surgical endo, and I got it back. I was really excited, and sure as heck, the damn thing doesn't fit. And I actually oversized this by almost 1 millimeter, and it still wouldn't fit. So that's one of the issues. It won't even fit with this other, it won't even fit, but don't think I'm foolish. Maybe I am. I was able to use this surgical guide, and it's actually in our advanced course. I go through fabricating it, and I talk about using it. Actually, it was probably even better than the trephine, because it gave me a whole bunch of indicators, and I was able to use this with a burr to get through the cortical plate, do the apico, and it was just actually, honestly, almost better. So take a look in our advanced course if you want to learn how to use this type of guide for an apico. So much faster. But the trephine didn't work. And I'll find another case to do this with, but almost maybe not that as effective. Okay, so the first issue is that it's shrinkage for the instruments that you would be placing through them. Second issue, so the second issue related to the first one is the different types of materials and the shrinkage. So let me show you what I'm talking about. So this is a guide to get through a fiber post, and this is the sleeve, and the sleeve fits right into there perfectly. That's amazing. So let me just do this for a second. So if we look at the tolerance between the inner sleeve So there's a tolerance between the inner sleeve and the drill. So the drill is going to move just a little bit. See how there's a little bit of play right there? My fingers are shaking. A little bit of play, hard to see, but there's a little bit of play just between the sleeve and the drill. That makes sense because this is rotating inside of it. So what I did was I oversized this hole because there's shrinkage of the material. And what happened was, in this situation, this is another dental lab, the material didn't shrink. It was actually stayed the same. And I was like, oh, okay. And then what happens is now because there's that bevel on the top of that little inner sleeve, everything's shaking like crazy. So if I glue this down, I actually don't know which way it's going to glue. So you need to take that in consideration, especially when these show up the day before you get it printed and you're like, oh no. So you need to really either call the lab and see, or print it yourself. How about that? That's the easiest way. So if we're printing, so if we use a different material, and in this case, the sleeve actually is tight and it's beautiful. So this is a nylon 12. I oversized, meaning I printed the whole oversized. This actually I think was if this is 3.5 millimeters, the diameter of this part of the sleeve, I printed this one at 3.75 and one at 3.85, and I'm not going to push it all the way down. Oh, heck, let's do it. And you can see it's got a tight fit, which is amazing because now I know that when I push this down, all the way down, we know that it's going to be lined up exactly the way I intended it during our planning stage in the cone beam software. So let's go ahead and take our drill. So that's the way it's supposed to look. Mint. Everything's lined up, perfect. Happy with that. And then what we're going to do in another video is we're just going to practice drill. I had this printed, and we're going to have this, again, like I said, we're going to create a video on how to do this because I think it's really helpful. It's not very hard, but I'm just putting this video up because just for the anticipation, because there are little issues to deal with. So when we have the patient come in, we're going to drill, well, actually we're going to access first, and then we'll get to where the post is, and then we'll use this, and then we'll measure how far down the post we're going to go. I think it's 12 millimeters from here to where the post is, and then we're good. Last thing, when you're exporting, especially with Blue Sky Plan, this is quite funny, is that this is supposed to look like this, or a fractured, one or the other. Oh no, it actually broke. So you need to export it properly, and I'll show you how to do that in Blue Sky Plan. But the thing is that depending on where you get it printed from, these are pretty weak. So it came in the bag, came in the package broken. So it's supposed to look like this, and it ended up like this. That's, if you're doing it that day, it's like, ooh, frustrating. I guess, we want to make sure everything's perfectly accurate. So other things, that's pretty much the main issue that I've come into. Go ahead and put in the comments below if you do lots of 3D printing, what are some of the issues that you've had and how do you overcome them? Anyways, thank you so much for joining me. We will talk to you soon. Cheers.